Dr. Jimmy's science class. Now, let's get started. One moment, please. Why won't this work? Oh.
Hey Google, play the video.
And now, welcome Oh, to Physics how
Uh,
convenient.
Today we will be talking about energy transfers. And now to pass it on to the narrator.
Hi everyone, it's me, the narrator. So, what just happened? Well, first of all, a Rube Golberg machine is a very complex machine with a variety of steps using simple machines to achieve a very simple objective. The cartoonist Rube Golberg would draw out these funny machines. His work became popular nationwide, and now people everywhere have fun trying to not only design, but physically create these contraptions. In order for them to work, energy must be transformed in a variety of objects, causing them to do different things, leading to the next step. Now, back to the professor to tell us a little bit about our different steps of the Rube Golberg machine.
Hello. So first, these dominoes will be activated, pushing the ball down this ramp, pushing this other ball down into the pulley, which will then come up, and this other side of the pulley will push this seesaw up, making this black ball fall down this, pushing the domino, pushing the marble, pushing the race car, pushing the many dominoes to hit the big marble into the cup, which will pull the little lever on the remote control, which will spin this wheel attached to an arrow, which will hit this little marble, which will then go down and hit this green ball onto the space bar to play the audio, asking the Google over there to turn on the TV, activating the video to introduce the physics class.
So, what kind of energy did we see in this Rube Golberg machine? Well, mainly we saw mechanical energy. Mechanical energy is the energy that comes from motion. It doesn't always have to be coming from something with gears. Instead, mechanical energy comes from the contact between any two things. For example, when one ball would hit something else, or the pulley, or even just dominoes. Those were all transferring energy through contact. Fun physics, like with a fun fact, but with physics. Did you know that Stephen Hawking is a physicist who was diagnosed with ALS, a disease that gradually declines the brain's ability to control muscles? Despite this, he kept working, leading to his theory about black holes, called Hawking radiation. He gave us a much better understanding on black holes when he proposed that the matter of black holes can become energy, which can be radiated away. We also saw some electrical energy. Electrical energy is energy that comes from the electrons moving from one atom to another. This can also be referred to as electricity. It is what is used to power things like cell phones, toasters, TV, and more. We saw this when the remote control activated the spinning wheel, which was attached to an arrow. Also, the TV and the video that played, that was all electricity or electrical energy. Here's another fun physics for you. Did you know that Marie Curie was a physicist and chemist who ended up discovering two new elements, radium and polonium? But she is most famous for discovering radioactivity, which she defined as the activity of rays to be dependent on uranium's atomic structure. She ended up being the first woman to receive a Nobel Prize and the first person to receive two Nobel Prizes, one in chemistry and the other in physics. Finally, sound energy was in this Rube Golberg machine. Sound energy comes from vibrations moving through something. Sound waves are when one of these vibrations moves through the air to your ear or another object or thing. we saw sound energy when the recording played and notified the Google to play the video. Now, real quick, Dr. Jimmy wanted to say one more thing to preview what we're going to be learning next class.
Oh, yes, thank you very much, narrator. Okay, now, students, Alfred Wegener was a German scientist who came up with the theory of continental drift. Basically, the theory that continents we know now can used to all be connected to form the supercontinent Wegener called Pangaea. Slowly, over long periods of time, land started to drift apart due to movement from tectonic plates. Wegener used 4 main pieces of evidence to support his theory. Here they are. The continents seem to fit together like puzzle pieces. Look at a map, you'll see that they do. Also, fossils of plants and animals that could not swim long distances were found at the opposite sides of an ocean, but would have been connected according to his theory. In addition, when the continents fit together the way Alfred Wegener suggested, landforms such as mountains and rivers matched up. And, finally, there was evidence of glaciers where ice shouldn't have been. Alright, well, that's all for today's lesson. I'll see you next time, and we'll be talking more about continental drift and other interesting topics.